Hey, Rain here. Earlier this year, I did a panel on new technology in fursuit making, and I filmed it for you. I wanted to edit it down a little bit, clean it up, add the slides over it, and share it with you guys all here. And that's what this is. I've taken out some of my ums and ers, some of the audio distractions, stuff like that. And I've also overlaid all of the slides that I use in the show. So if you were there and were curious about seeing the slides a little bit more, this will be a great way to see it. And if you're new to the channel or just want to learn more about things like 3D modeling, printing, dye sublimation, vacuuforming, all sorts of things used in both fursuit making and cosplay, this is a great place to start. Thanks for joining me. All right, so I'm gonna go ahead and get started. Hi, I'm Rain. I run the Fuzz Factory. I've been a fursuit maker since 2011, and I've made something like 130 fursuits. This con I just delivered, I think it was my 134th fursuit. I started off like a lot of other makers, sculpting by hand with green foam that I found at Joann's. I found fur from any source I could. Joann's, you know, at the time there were still people using, and myself included, things like rugs from Target that were really fluffy and you rip the backing off and you make it work. I have been through used Mendel's, and now I use Howell and CR Crafts and all these other fur suppliers. I focus on a lot of toony stuff, but my background is in theater. I have a master's in technical theater. I used to design and build sets, a lot of engineering focused things, CAD programs, stuff like that. So I was always a computer heavy person. I love working with computers and technology. But going into fursuit making, it was kind of like a switch. There's a lot more like artistry, craftsmanship things that are a little bit different to do. But it's been fun in the last 5 years or so to kind of dive and change the other direction. I don't know if you knew this, about 6 years ago, there was a pandemic and a lot of us got stuck in our houses and had to do something for entertainment. And I started to learn how to do things like 3D printing and 3D modeling. I was learning in Blender. I was trying to make avatars for VR chat. Unsuccessfully. So I started learning that way. I got my first 3D printer. My husband actually got me, my boyfriend at the time, got me a 3D printer. It was just one of the resin type 3D printers, and I would make little minifigs for D&D campaign kind of stuff. We graduated to Ender 5, learned with that, failed a lot with that. That was a little bit more frustrating. Eventually moved up to, I have a Bamboo Carbon X1, and that thing is a beast. And going from that to some of these more modern printers, like the Bamboo ones, has made things so much more easy and approachable. A lot of the failures that we used to have in printing just don't happen anymore because the printers catch them. They understand how to change how they work in order to adjust for their bed heights and things and flows. They even, my printer will even message me and tell me that there's an error, and it'll stop itself. And then I can look at the video from my phone and fix it. It's kind of amazing what technology can do nowadays. But we're gonna go through everything that I can think of, and I want you to, if you have any questions or comments, I want you to try to hold them to the end, just to help me get through the presentation in about an hour. But do write them down on your phone or whatever, and we'll try to get to them at the end. Or if you have a comment about something that you've tried that worked better for you, I'd love to hear it, but I want to save it towards the end just so we can get through everything, because sometimes we all want to talk and we're excited about this thing. I know I'm up here talking about it. And we just want to make sure that we can get through the whole presentation by the end of the day. So I am Rain, like I said. I'm a fursuit maker. These are some of my kids. This was taken last year at this con. I took the same photo this year, just earlier today. You can see I kind of have a lot of different style. I was inspired by Disney toony stuff growing up, and you can see that there. But I also enjoy playing with things like a little bit more form-fitting suits. I kind of don't like doing the same project twice. I really enjoy a challenge of trying something new, even though that can be really stressful, which has pushed me into doing 3D printing and projects like that, because it allows you to do some really cool stuff that I couldn't do as easily before. These are a couple more projects that I'll talk a little bit about with you today. They're all projects that were mostly done by computer or 3D printing. The project on the left there is, his name is Tex from Hell of a Boss, sorry, from Hell of a Boss. And he is a cosplay I made for last year. He features a lot of weird stuff. There is, his ears move, his tail moves. The entire lower body was 3D printed. The head was 3D printed. I used things like the 3D printing. I used dye sublimation on him. I used a lot of weird stuff in this project. Projection, scaling in order to create my shapes and patterns. So I'll be referring to him a lot throughout the panel today. The top one is a mask that I made. I really enjoy making masks, all 3D printed, modeled on my iPad. I'm a huge avid iPad user because it's made it really approachable for making these kind of things. There's some like Cobalt Core busts. I don't know if you're familiar with the game Cobalt Core. I made some busts for the people that made the game a while ago, and I have like I also enjoy doing things like props. Like this is my golden dolphin I made as a replica from the bad guys. I also made that Mr. Wolf that goes around, and Mr. Snake too. He's here, all made. He's actually 3D printed, 3D modeled over a scan of myself. So it's kind of crazy to see what you can do with 3D printing and 3D modeling. And in fact, I have one more thing I want to show you. Another project that I was delivered at this con, and I have a lot of references to this project that I'll be talking about throughout the rest of the presentation. And you can come on up. Yeah, this is Pillow. This is an armadillo that I made. I delivered him just before the convention. Hi, Pillow. You can see he's an armadillo. He's got the shell that goes from the top to the bottom. And it required a lot of unique, weird techniques. Things, come on over here. Come on into the center. Yeah. Hello, you're looking great. There's a lot of 3D printing, 3D scanning. His feet, his head, his shell were all designed in 3D modeling programs. And I'll talk to you more about how exactly those work, but we can't tell him because he's just Pillow. But I just wanted to show you him here, and I'll show you pictures of him more later as we go on. But I'm so glad you could come out here and just come out here and show off yourself. Turn around one more time for me. Yeah, look at how cute he is. Yeah, you might have questions on how the armor goes from the tail to the top of the head and everything, and I'll go over all that stuff with you. But there's a lot of hidden technology in this suit, and I'll tell you all about it in a little bit. Thank you, Pillow. It was great to see you. Give him an applause. Yeah. Great. All right. So let's go into what we're going to be talking about. I'm going to be talking about some technology basics. We'll be talking about 3D scanning. We'll be talking about 3D modeling, different software I have used, stuff that's out there. Some of the stuff I know more about, some of the stuff I don't, because there's just a huge amount of resources available. We have 3D printing, and I'll do a lot of talk about the different types of 3D printing, how they work, different types of filaments, and what works best for different things, and in my opinion. We'll also talk about different types of patterning and how technology has made patterning easier. And it's becoming even easier with new programs being worked on like as we speak. And we'll talk about some miscellaneous subjects like dye sublimation and servos and adding electronics to fursuit, stuff like that. So let's jump right in here. 3D scanning. 3D scanning is one of my favorite things to do with fursuit making nowadays. I have this guy here. It's a Revo Point. It's a Miraco 3D. It's a scanner. I can just take it out here. I can use it to scan whatever's in front of me. Let's see here. So I can I don't know if you can see that. There's a chair right there. I can use it to create a model of something. What I absolutely love it for is things like you can see here, I scanned a croc. If I want to build a fursuit shoe, I can build it directly off of the shape of the shoe that I'm using. Super nice because then I know that the shoe fits the size of the wearer. Sometimes you want a really petite feet and you want it nice and like snug to the shoe. That's how you can make it perfect. So you can see here, there's a scan of a shoe that I did for a current suit. And this little guy just does it all on board. It's a really cool piece of software. I also use it for things like human heads. I scan clients, and I'm able to take that scan and put it up together, use it. It's scanning in scale, which in 3D modeling is something that's kind of hard to get right, because like Nomad Sculpt, it doesn't seem like, it doesn't start in a scale that makes sense, even though, fun fact that I learned by testing, 1 unit in Nomad Sculpt is 1 millimeter in printing. So if you're building something in Nomad Sculpt, build yourself a block that is like 10 by 10, and you have a 1 centimeter thing. But why do that when I can go off of a scan of my own head? I build hand paws now, that I just made a new hand paw mold off of a scan of my head, and I know it fits perfectly, and they're like my favorite hand paws I've ever made. But scanners are a pretty cool way to do this. It's not something I actually started with, but it's something I kind of went into with frustrations with using sculpting software and not having scale, not knowing if a head was going to actually fit something, and then like importing it into Blender or into your slicing software if you're 3D printing, and being like, oh, my fursuit head's this big. Why is my fursuit head this big? I have one of my first prints I ever made was a fursuit foot paw that I was trying to see if it would look good. So I was like, I imported it into the slicer, and it was literally that big. And so I printed one, and it's still in my shop somewhere, because I was like, it's the funniest thing. It's just seeing this, like the tiniest foot. It's like a micro fursuit shoe. So 3D scanning breaks some of those barriers. Now, I have a pretty decent one. There's much more high-end ones than this one. I got this one secondhand, which made it more affordable. I've used the Revo Point Pop 3D. I didn't like that one. I don't recommend it. But this one does everything on board, which makes it really convenient. There's also Creality has been making really good 3D scanners lately. I have a friend that does like car, like overlanding stuff, and he scans parts of his car and replaces them with 3D printed parts. So that could be a good thing. But there's also some pretty decent Android and iPhone options. I've got them listed there. Polycam, 3D scanner, WiDAR, and another one that I found out recently, EM3D, is a maker named NazFX recommended that to me. So they've been doing some amazing stuff for a long time. So I do recommend that one as well. Some of the things that you got to remember with 3D scanning is keeping things, different scanners work in different ways. A lot of these ones have a really hard time with shiny things. Some have a hard time with things that move really fast. So learning how to like work with it and practicing with it is kind of a skill. So be mindful of that with any of the apps that you use too. There's some really good iPhone apps though that can do a pretty good job of it. Personally, like there's these things that they'll scan in color and stuff. I don't necessarily care about that. For me, it's just about size and shape. Though if you wanted to scan a fursuit and bring it into Blender and make it into like a VR chat avatar, having the color scans could be really useful for that kind of thing. So 3D scanning it's just absolutely a really cool frontier. It's a little bit newer for me, at least, than 3D printing. And the more these phone apps, like the iPhone has the LiDAR kind of thing built into it, that makes it a little bit more correct as far as like its scans go. So I do recommend being able to go from that, because as you're working, if you're working in 3D, having some stuff in scale to begin with will fix everything later. If you're starting outside of scale, if you just sculpt something that looks good and then you put it in, it's going to be harder to figure out, well, what's the math to make this the right size consistently across all parts? Because like if I print the ears different from the head, now I have to remember that, oh, I multiplied that size by 2,864, and that made it the exact right size. And I have to keep notes of everything. So if you work from the beginning in the right scale, you can do some really cool stuff. Up next is 3D modeling. 3D modeling is one of my favorite things lately. I use Nomad Sculpt almost exclusively because like I said, I'm an iPad. I love using the iPad, though I believe they've moved it over to Windows recently too. So you can use Nomad Sculpt on anything, basically. It's a really intuitive, it's more like an art program than some of the other programs are. I absolutely like it for just creating organic shapes. And it's also a good price point at $20, as opposed to some of these other ones that are a little bit more expensive. But Blender is free. So if you can learn Blender, you can use that to create your sculptures too. Blender is one of my favorite pieces of software because not only is it free, it is like a Swiss Army knife. There is so much you can do in Blender, from modeling to animating to texturing things. There's just a lot. Like Flow, the movie Flow, I don't know if you're familiar with it, that was done entirely in Blender, in a free software. Like, it's absolutely amazing what people can do with that kind of thing. So Blenders, I highly recommend. I like Blender a lot too for my secondary use of modeling. If I need to fix up models, or like, oh, I realize I want to put a bolt hole in this thing or make these two pieces fit together. For example, Pillow's ears, they actually come out. They're held in, there's magnets inside the head plate and in the base of the ears. And you can basically pop them out. And then I have an additional bolt in there that can hold it in place. They're little camera bolts that fold flat. So they're nice and hidden up inside there. So if anybody was to grab an ear or he hits an ear on a doorway, it won't fall off. But if he's just doing a photo shoot, he can change the ears out super easily. He actually has a couple pairs of ears based on that. Let me actually find it real quick. Yes. So there's Pillow. This is the 3D model of Pillow that I made. You can see how this is all in Nomad Sculpt. Let's see if this is the pre-labeling things correctly. So I got to figure out what's going on. Okay, there's one set of ears. There's the other set of ears. So he's got two sets of ears that I figured out in this program. I took it into Blender then and built a base plate using that program they basically have a bunch of notches that fit in together and then recessed areas that I mounted magnets into, so that you just line up the pegs and they slot into place super fast. It allows you to change the ears and expressions super easily. But that technology really, being able to use Blender and having it be a free program made it so much easier. There's also ZBrush and Maya, which are paid apps. I think ZBrush is like $60 a month or something like that. Yeah, it's a lot. I see some amazing work with it, and I would love to play around with it, but I don't have that kind of money. So Nomad Sculpt is kind of my go-to for all that stuff. But then there's also, on the other side, there's technical software, Shaper, 3D, AutoCAD, SolidWorks. If you're wanting to make technical parts, maybe you're making a motor mount for ears, something like that might be way more up your line because you're able to, put the exact measurements for things. So if I look at Vortex here has a little pack here that controls his ear movements. It pairs with my phone and allows the ears to rotate. The ears are just little servos mounted to the top of the head, and I built little housings for them in the ears, which are printed out of TPU, so they're soft and flexible. And then I can pop them on, and if there's any issues, I can easily demount this and replace the servos and make it work. But I did that in Blender, I built the casings in Shaper 3D. That's like a $20 a month program. But there's some free CAD softwares also available, like in web browsers that have different limitations. But absolutely, a software is super useful if you're doing some weird technical projects. You're making housings for electronics. You want to have some light up parts, but you need to make sure that you're not getting them soaked because the person wearing is sweating or whatever. Well, you can make that kind of stuff in those programs, to fit your hardware perfectly. So I absolutely like using kind of a mixture of the two. I used AutoCAD like 20 years ago. And that was my primary software for building stuff. And so to go from that to what we have nowadays, like the Shaper 3D is kind of like, I don't know if you used Google SketchUp before, but Google SketchUp is incredibly fast way to mark up things and make shapes and spaces and whatever. That Shaper 3D works like that, but with more engineering focus. So super useful. So that's 3D modeling. And now 3D printing. This is my get ready. This is one of my favorite things to talk about is 3D printing. There are three major types of 3D printing. In fursuit making, we probably only really use two. But the first one is called stereolithography, SLA printing. It's resin printing. You can print some acrylic. I'll break down each one of these things into what they're doing. But resin printing basically uses a goop, and you use UV light on the goop, and it makes the goop hard where you want it to be hard, and you basically create structures from that. I'll go into what that really means in a little bit, but that's SLA, stereolithography. The second one is SLS, selective laser sintering. Selective laser sintering. This is like the coolest one, in my opinion, but it's also the most cost prohibitive one. Like the printers cost like $20,000. So not really something we as fursuit makers use, but it also makes like the strongest parts and there's some cool stuff. So I'll nerd about that a little bit in a minute, but it's just good to know that it exists as far as one of the three primary 3D printing parts. And then there's FDM, fusion deposition modeling. And when we think of 3D printing, that is the type of 3D printing most of us think about. It takes in filament and it heats it up and it poops it out on layers and it makes the structure from that. That's fusion deposition modeling. So, and that's what you see up here on the image is fusion deposition modeling. I'm actually printing a fursuit head there, suit I delivered early this year named Gare Bear. But his head was made entirely out of 3D printed material, TPU. So those are the three different types of printing. Before I discuss what those are, there's an important little thing called slicing that we got to know about. Slicing is what takes a 3D model into a 3D print. It is slicing software is what allows it basically takes the model. We are able to then change it around, move it around, figure out how we want the walls to look, how we want the finish to look, how thick our layers are, how detailed things are. That's all determined in slicing. Every 3D printer uses slicing software. There's just a bunch of different ones, though some have overlap. So I use a Bamboo Carbon X1, and I have a Snapmaker U1. Those both use a software called Orca Slicer, but they have their own versions of it. So there's like a Snapmaker Slicer, and there's the Bamboo Studio. They're just the Orca Slicer with the skin on it and some other features built into it to make it more focused on using their printers, but they're the same base. I also have a Prusa slice, this is a Prusa XL. So I have the Prusa slicer here shown, and they all work kind of the same. They're just a little different in their format of like where you select the filament and how you want the filament to work and that kind of stuff. But basically, as we use a slicer, we determine how high each layer is, because every type of 3D printing I've talked about basically works in layers. It basically takes a slice of a layer at a certain height and then figures out what it looks like, and then takes the slice of the next height and the next and the next and the next. And depending on the printer type, it makes a code that the printer uses to create the print, okay? It's not too complicated, but there's a lot of math and stuff going on back there. But basically, it's like you just take a thing, you cut it into a bunch of pieces, and you layer them on top of each other until you get your finished project. But each printer type does it a different way. So I'll talk about that in a second. But yeah, slicing is how we determine how thick our walls are, how strong the material is, how detailed things get. So we'll jump into how exactly we work with SLA printing with that. So this is SLA printing I think it's kind of like, it's like one of my favorites because it's incredible. It's an incredible process. You can only work with one material at a time with this type of printing because how it works is if you look at that printer, at the bottom there, right above where it says Anycubic, is a vat. There's a vat of resin, liquid resin that is UV reactive. And underneath that vat is a computer screen, basically. It's a computer screen that does one color, and that's UV. It has a very high resolution, and the higher resolution the computer screen, the more resolution your print becomes. So they pack a lot of pixels into a very simple display underneath that vat. The vat has a clear plastic bottom. That clear plastic bottom is replaceable because it eventually gets damaged, that kind of thing. But you basically take the bed, which is that at the top of that, it's called the bed for this one. The plate there, the bottom of the plate goes down to the screen, and then lifts up like a fraction of a millimeter, and then light blasts it underneath from the slice. Okay, so the first layer is sliced and it has an image of what it's supposed to look like. That image flashes on the screen, and then the plate moves up. It peels that material away from that clear plastic sheet, and then it moves it down just a fraction of a millimeter higher, and then blasts it again with light. And light blast is like 3 seconds, and then it does it again, and it does it again, and like a print like that, probably like 20, 30 hours, and thousands of layers, but you get incredible detail with it. It's way more detailed than the FDM style printing. This is why they make like minifigs out of this. Molds are often made out of this for casting certain things. You just get crazy detailed parts. You also get because it's resin, the resin is a really cool material to work with. It's sandable, it paints really well. You can get translucent resins. I actually have a couple parts where I built the mask I showed earlier has resin. Actually, I'll just show you the picture. It has resin in the eyes and mouth. So you can see there the video of that red resin is being able to be lit up from behind. So it is really cool. You can do a lot of cool stuff with resin because it just allows you some flexibility. Sandable, paintable, very cool material. But toxic, very toxic. So this printing, you really need to make sure that you have a ventilation, wearing a mask, you're wearing hand protection. You have plans in place to deal with the liquid resin cleanup. It's kind of a lot of prep work to do anything. So this printer here, I have this model. This printer here, it also comes with a bath. It's basically like a curing station. It has a tub that you break the piece off of the plate, crack it off with like a scraper. It'll pop off. You pop it into some alcohol bath, and in the alcohol bath, you put it. It's basically on the bottom of the machine. It has an agitator. It spins the alcohol and rinses the thing off. So you clean off all the extra resin that is not hardened because it's dipping in and out of this bath the whole time. Where it hasn't been hardened, it's still going to have resin around it, but you need to clean that off. Once it's cleaned off, then you have to cure it again. So you take the bath off the machine, there you put a different plate on the machine, and on the back of it, there's UV lights, and the plate at the bottom slowly rotates, and you can cure it for another 10 minutes under that light, and that becomes really hard and workable at that point. It's a really cool material. I absolutely love it for weird stuff, high detailed stuff. I love making like D&D stuff with it. Or if you're making like figures, I've been working on like a bunch of little like pendants and things. They're really fun to make with that material because it's incredibly sandable. It's easy to work with. It's kind of great to paint. But like I said, it's toxic. It is very difficult to work with. It is a mess. You need to make sure that you have all of that stuff in place before you get started, or else you can have problems. Like I have a fume hood in my, I call it my lab. It's basically the smallest room in one of the small rooms in our house that has all the 3D printing and stuff. And in it, I have a fume hood box that goes to the outside that I vent my machine into, and that helps with the smell. But if I'm running that machine, you could smell it in the house, and if you can smell it in the house, that's not great. So that is resin printing. Like I said, one of my favorites, but it's a little bit harder to do. But then there's SLS, which is significantly harder to do, but it's so cool. SLS, like I said before, is it's a printing that is incredibly expensive. It uses lasers. Yeah, it uses lasers. That's the only reason why it's on this list. Basically, it uses a nylon dust, and it takes on the leftmost machine there. This is a whole setup. This is like what you need to do this. This is a full kit for SLS printing. The machine on the left takes a bed of nylon dust, and just like with the resin printing, it sets up a layer, and instead of a UV screen, it shoots lasers on that level onto the dust, and that dust then fuses together. It melts together and creates this nylon structure. And then it drops down a little bit, and then there's a thing that sweeps more dust over exactly the fraction of a millimeter height that you have it set up to do in the slicer. It puts that dust over, and then it lasers it again. And then it puts it down and lasers it again. So you create your structure in this bed of dust. What's really cool about it is, unlike the last printing, you saw the last printer, there was you can see the structure that is used to support it. All those supports, those things dangling down, that's the supports. So that's all there to help make sure that when you get to a layer where there's nothing above it, it holds on to it, it allows it at a point to attach to everything else, and it doesn't just get stuck to the build plate and ruin your print. The supports support the print. In SLS printing, you don't need supports because the dust stays around the piece until you pull the whole thing out. So the dust is the support. Where it doesn't fuse, it is just the support and mesh. You can then use that whole print area as your print supports. You can print like as many things as you can fit in that area, you can make it work. Whereas this is really just like, you want to do one thing and you're good. With the other type of printing we'll talk about, you can do multiple things in the same bed, but you can't stack something over the top of another thing particularly easily. This format, you can just pack it full of different parts. So it's really cool for prototyping. If you're doing like automotive stuff, it's really neat, but not as cool for us. You also then need to use that center machine, which takes the printing chamber. You can see the printing chamber in the bottom left of the center machine. You basically take this thing out, you put it in there, it pops it up, and then it's a sandblaster. And you separate the dust from the print. It recycles the dust for the next print, and then you take that print and you put it in the next chamber, which has another sandblast, like a proper full powered sandblaster, and it's almost like a polisher, like a tumbler for rock polishing. And you pop it in there, and it'll spin it and clean it up even more. So, but you need all those machines to do it. It's a lot, and they cost like, I saw one on Kickstarter for like $9,000. It's like the cheapest one. And I'm like, I don't even know if I would want to go with the cheapest one of these, but I also don't think I need it, but it's cool to know about. But everybody's favorite, it is FDM printing, fusion deposition modeling. These are the two of the printers I currently have. I actually Kickstarted another because I have a problem. And I have a Snapmaker U1 that just came out, which is a cool printer. Both of these printers are different in cool ways. But they all work. The other two ones only have like one type of material you can do at a time. These guys can do lots. There's a lot of different materials you can choose from that are to print from. You can have different support material. You can have stronger materials, lighter materials. There's all sorts of stuff that you can do with it. And I'm going to talk about specific printing filaments in a minute. But basically, these printers are pretty fast. The newer ones are so smart. They like tell you when there's problems. They stop. They notice like something called spaghetti. Who's here is familiar with spaghetti or experienced spaghetti? Yep. Spaghettiing is basically when your printer no longer has something. The supports have failed usually, and so the thing it was printing on has moved out of the way, and now it's just printing in air. I remember in the old Ender coming back, and there'd be like 100 grams of print filament wasted just in the air, and you can't recycle it, you can't do anything with it. It's just now wasted. But the newer ones will tell you, I'll get a message on my phone and be like, hey, there's a problem. Can you look at this? And you can even cancel parts of a print nowadays. Like the Bamboo software is really smart. You can cancel a part of the print. If you notice one part of the print has failed, you can be like, well, just don't do that one anymore. Continue to do the rest. And it's so cool. They are pretty easy to work with. There's a lot of forums and stuff if you have issues. There's customer support is pretty darn bulletproof too, from my experiences. There's a lot, like I said, a lot of filaments you can use. It is very fast, easy to clean, easy to work with, but there's a little bit of fuss with knowing how to use it the best way because the pieces don't bond in the same way. That you're working in layers, and so you have to work with the strength of your prints in order to make things work as good as possible. And it can be a little bit wasteful too when you're doing things with lots of supports, stuff like that. So it's something to think about. But this is the most common type of printing that we think about when we think about 3D printing. And for good reason. It's incredibly useful, very versatile. And we're going to talk about some of the things we can put into these printers to make them work. So the first type of filament is a PLA. It is what most the most popular type of filament. It's when you see something that's glow in the dark or the cool shiny color changing things, all that stuff. There's like wood filament PLAs. There's super light PLAs. There's translucent PLA. Like you can get all sorts of stuff with PLA. It is pretty cheap to buy, anywhere from like the super cheap stuff. I think I can get like $8 a kilogram. Maybe not use that for professional stuff, but it might be great for molds or even supports for other more important parts. Up to like $30 or $40, but you're really the normal price point's about $20 to $25 for a kilogram of PLA, which is pretty affordable. And a kilogram goes a long way for things. So there's a ton of ways I use it. I used it. PLA is in this guy. I've got his nose is actually made out of PLA. I used a vinyl car wrap around that to give it the texture that it has, but that's made out of PLA. I think his teeth are actually made out of PLA. I then sanded and smoothed them. I have one of my favorite PLAs it's by Polymaker. It's called Cosplay, COSPLA. It's really nice because there's two versions of it. There's like a very easy to sand version and a very strong version, but they're higher sandability printing materials, which is kind of great. Oh yeah, one of the other things, I got sidetracked. One of the other big negatives with printing, 3D printing with this type is filaments are fussy. They are hygroscopic, which means they pull in moisture from the air around them. And the wetter they get, the worse your prints get. So you have to be on top of making sure you're drying your filaments or keeping your filaments dry. I've had a few before where you like pull it out of the thing after a year of not touching it and you grab it and just cracks, breaks. But drying it, keeping them in airtight boxes. There's a ton of these like vacuum bag things, silica packets, that stuff. You can keep them dry that way. That'll extend the life of them. But it's something to be mindful of when you're working with 3D printing with that type. PLA is also that same sort of thing. PLA's weakness is it's kind of not that strong. It's one of the weaker versions of it, but it's not toxic. It's really easy to work with. You can decrease your layer heights and create really detailed models. And one of the other cool things about these printers is the FDM printers is you can change the nozzle size. So the typical nozzle is like 0.4 millimeters. But I have like a 0.2 if I wanted to create something super detailed, or if I wanted to make something super fast, I can go to a 0.8 and make it just like happen real fast. So there's lots of options with that and like fine tuning what you want. I think I've only used a 0.4 for like 99.9% of my printing. So like, and I actually my Carbon X1, I'm still on the same nozzle that I had when I bought it, and it's 2,500 hours of printing on that nozzle. So like, if you take care of it, if you're not putting stuff that's too hard through it, there are some printing filaments that eat up nozzles, but I have a hardened nozzle, which is nice. Something to think about when you're using printers, but they can last a long time. And yeah, you just want to make sure that you keep them dry. Dry is important. The second one is TPU. You actually see here that's the head of Pillow, the one you just saw here a little bit ago. TPU is a flexible filament. It's kind of rubbery, but it's pretty rigid, but you can actually get it in a bunch of different types. You'll see a lot of it. Actually, if you go downstairs in the dealer's den, you can see fursuit heads printed in TPU. They'll be like meshy like this. What's really nice about that is, actually, this is Vortex. This is the suit I'm wearing. This is his butt. It was printed in TPU. You can see that it's flexible, it's soft. What's nice about this is I'm only printing with a 10%, or this is like a 12% infill with a gyroid style infill. What that means is only 10% of the area is material. That means that it's very porous. Air can pass through a lot better than foam. When I was making foam fursuit heads and foam body parts, I had a lot of like, you feel that like the heat gets trapped way more than this. In fact, Vortex's head is also made out of foam or out of a TPU, which is interesting because right under here, I didn't use any glue. It's just loose. But because it's TPU and because I've hollowed it out in my model, that allows a lot of airflow from the bottom through the fur into the head. So while a closed mouth fursuit typically has horrible ventilation, he's actually not the worst. Versus like Mr. Wolf that I made, who was carved out of foam and I had to carve open his mouth a little bit just to allow airflow because that was just like stifling how bad that was. But yeah, he's TPU. I can like I said, you can squeeze it, you can feel, you can come up afterwards if you want to like touch it. And you can see that they're soft materials. The ears are that way too. It makes it really nice because they're also super light. Because there's not a lot of material in here. The fur weighs more. Usually, fur and adhesives tend to be the heftier part of the fursuit heads at that point. Some of the fursuit heads I've made this way are just like not even a pound as a head base. So I made a meerkat last year that I think the whole head weighed 1.3 pounds, but I did it off of a scan of him, and the goal was to make it as small as possible so it looked natural with normal clothes kind of thing. But yeah, TPU. TPU is incredibly fussy. It is because it's so flexible. It's kind of weird. It doesn't like, it bonds in weird ways. It loves sticking to build plates. It doesn't like sticking to other stuff. Adhesives, like if you make a very smooth print, see, like he's open celled. If he's smooth, it becomes much harder to glue stuff to because it's kind of seals in a different way. Whereas PLA, you can glue stuff to pretty well. It binds things really well. TPU is a lot more fussy when it comes to sticking stuff to it. But you can use certain adhesives like E6000. You saw a little bit ago, or actually you see here, I tend to slice my fursuit heads about right here. There's people that print full fursuit heads in one piece, and I don't like doing that. It increases the hours. I did actually it was this suit here. I did a test to see the differences if I printed it in one piece versus splitting it in two. I think the printed it in one piece added it was like 8 hours, and I think it was a quarter kilogram of material because of all the extra support material that you had to use. So I typically just cut it right there, the whole back. I don't even use supports on at all. And then the front has a little bit of supports in the muzzle area. And that usually works pretty well for me. But I like that because it's a little bit more economical, saves material. I'm not wasting as much. And it also is just faster. So it's kind of cool. But E6000 is a material that works really well with that. Also one you need to have good ventilation for because it's very toxic. So the other cool thing, and I should have had him stick around for this. This guy is also made out of TPU. I made Mr. Snake here off of a model of myself, but you can see how flexible he is. He moves really well. He's squishy. I'll let you guys come over here afterwards and squeeze him. This is foam filament. There's a couple makers of new TPU that's called Shore was the first one I found out about. Tech is another one that's available on Amazon and is almost as good as the Shore. Shore is about $70 for 0.7 kilograms, and it's imported from Germany. I think Germany, Denmark. So it costs a lot to bring it over. But what's really cool about the foaming filaments is the more heat you put to them, the more they expand. So you get these materials that look like foam. They're just foam. They look like they're casted foam because they don't have the layer lines, because as the pieces expand, foam expands, it creates this nice material. And you get these like incredibly soft foam pieces that are just magnificent to like work with. They take adhesion better than the normal TPU does, but they're also fussier and more expensive too. So they're kind of like the newest kind of TPU. I absolutely love them. But yeah, Shore and Tech are the two, SiryaTech. Those are the two that I've used the most and really enjoy. Yeah, he's all that's entirely 3D printed, so he's super soft, flexible. But it's kind of neat that like 3D printing can be that like comfortable. Um, so yeah, I use it also in feet. Like I told you, I showed you a picture before, the scan of a scan of a fursuit foot. I use that. The TPU is great for that because you can build it around a shoe and it's still flexible. It still like takes impact. It's not going to crack in the same way that like a PLA might if you hit it with something. So pretty useful. PETG is another one that I use. PETG is like PLA. It prints very similar. It's just stronger. It's a little fussy sometimes, but if you want something that's a little bit stronger, that's going to be structural, you can use it for that. So Vortex has extended hands. They use a mechanism that does this. I printed this out of PETG because I didn't trust PLA to handle that. So this is just the inside of his hand paw. I basically have one for each finger, and then this wrist strap velcros around my hand to keep it all in place. I have TPU fingers, so they're still soft at the front, and they just like I actually. What's really cool about 3D printing too, there's so many people out there making amazing models. So I bought the model for the mechanism and then completely redid it using the geometry, changed the hands completely. These were like skeleton fingers before, and they obviously weren't. None of them were meant for 2 fingers wide. But I did a lot of trial and error until I got to the point where I had like the fingers that work. But I needed him to have big, stupid hands because the character's hands are just giant. So doing something like that was really useful for me to get exactly what I needed. So, but PETG, really easy to work with. I also love it as if you're using a printer that can print in multiple filaments, PETG is a really good layer between the support structure and your finished product. You can actually use, it's called an interface layer. It's like my pro tip. Using an interface layer with PETG or Silk PLA can let you create a new base layer that makes the bottom of the print really, really nice. If you're familiar with printing and you've used supports, the bottom of things tends to be a little bit funky. Having a really nice, strong support layer with something other material that it can't bind to in the same way can be really awesome. So PETG is really cool for that. I always have a little bit of PETG around just for like that reason. So yes, PETG, super useful for structural support parts. The other one that is more useful because it's stronger is ABS. ABS is so cool to work with. It's really popular in cosplay communities. You can see there, I don't know if anybody played Satisfactory. I have been slowly picking away at a Satisfactory helmet. I got this model online, but that's printed with ABS. What's really cool about it is super strong. It's an incredibly strong filament to use. It is also incredibly easy to do the post-processing. Like you could just sand it with like an electric sander. It doesn't have the heat, some of the same heat issues where PLA has a much lower heat point, melting point. So sanding it aggressively heats it and then melts it and makes it weaker. Whereas this heat point is a little bit higher, so it's a little bit more resistant to that kind of thing. And you can use acetone to like smooth it, bond. You can basically glue the pieces together with some acetone and then clean it up. But it is also not the greatest as far as odors and working with in that sense. So you need to make sure you have ventilation or use low odor versions of it because it is a little bit more fussy as far as that stuff goes. It stinks to work with. So, having protection is really important for that kind of thing. So we'll move on to the next step. So this is Vortex again, as I was working on it. There's some cool, moving away from 3D printing, there's a lot of other cool technology or that 3D printing can enable, but we can also use some other outside resources to help us figure out how we're going to work with stuff. So if you're like me and you've done a lot of fursuit making, duct tape patterning, right? You've taken a material, you've taken a fursuit head sculpt, you patterned, you take tape over it, you draw on it, you make your fur patterns and you build it that way. Well, you can use that to create body shaping as well. With Vortex here, I used the whole upper body. I used a patterning system where I printed it in scale. So the one on the left, this little me. There's a little guy. He lives in my house or in my studio, and I used for the whole upper body for him. You can see on the right picture, I used foam, charcoal firm foam, 1 inch thick, to create the upper structure. And then the whole lower body was 3D printed with TPU. So I was trying to figure out, I wanted to play with two different styles to see which one I liked the most. And since it was a project for me, it was kind of fun. And honestly, I like both of them for very different reasons. The foam version of it, I think, turned out really cool because you get these stylized, crisp corners. It collapses really well. You can vacuum pack the whole upper body into a small bag. But the lower body breathes way better because it's that open cell style TPU build. So let me show you here. I have photos of him being made. So you can see here, this is the duct tape patterning traditionally, right? If I'm doing a head, I'm covering it with tape. I'm marking out the lines, figuring out where I want them to go. There's the nose, 3D printed and covered in the vinyl. The head sculpt, some of the wiring. There's the upper body right there. So that's the upper body just in those pieces. But if I go look at how I worked on Pillow over here, Pillow, I did a similar method where I took the 3D model of him. I have his like back there. I actually printed out a tiny version of his back so that I could create that shape I could basically take a little tiny duct tape pattern. It was like this big, like each piece was about this big. And then I projected it up onto my wall, onto a piece of craft paper, in scale. I printed it in 1/6 scale, and then so I just blew it up 6 times. And you can see all the different parts there. One labeled 1, 2, 3, 4, 5, and then I used that to create his back shell. So you can see like there's those same exact parts. But I used the patterning of it 3D printed small to make the much bigger version of it. So I didn't have to waste a lot of material making this like full-size 3D print or anything. I could just do it pretty quick. And you can just use some like contact cement or barge cement to glue those foam pieces together to create those shells. Turned out pretty cool altogether. So you can see a little bit more of the inside of that. The tail there too. You can see here, this is a mixture of those materials. That's the flexible foam. You can see on the top there. On the top left of that picture is the foaming TPU, right? It doesn't really look like it's 3D printed in the same way. At the bottom of it is ABS base that I adhered to each other. I basically had one fit into the other, and then I glued them together. So the base of it is super rigid and strong where it mounts to the head, and then the foam part is soft and flexible and can play around with. And then you can see there the magnets and the pegs and how they interact with each other so that they just like snap into place super easily. And the right side of that photo, you can see the foaming TPU again. That's actually the piece that's mounted to the back of the suit, the shell, that magnets to the top of the head. So to take the suit off, you have to basically pop the shell, that little black piece there on the right there, pop that off. It'll open up and allow him to take the head off, because otherwise the magnet piece locks to the top of the head and there's a seam that's right at the top of the head that's really hard to see because the shell has those nice lines in it. I hide the seam between the two pieces in that line. The magnet allows him to move around. It has a little bit of movement to it. So he can move his head pretty freely, but at the end, he's able to, it just always still looks really nice and seamless when it's all together. So yeah, there it is in one piece. So that's how I do foam patterning at scale and blow it up to make it a little bit better for use in fursuit making. There's also software. Cozy Blanket is a piece of software that you can use to UV unwrap a piece of 3D model. There is I talked about scale model printing. And there's a new program being made right now called PandaFold. It's a furry that's making this software that takes a 3D model, and you can literally just draw on it where you want your seams to be, and it'll make a projection on a printer paper size thing, on whatever size of paper you want. And you can just pattern your fursuits based on without having to do traditional like duct tape patterning. You can just say, this is what I want the fur to look like, and it'll print it out. It's absolutely cool. It's still testing. He's still working on it. He's got a Patreon where he talks about it. But it's an absolutely cool way to do it. It's going to be really neat to see software where we can just come up with the costumes before we even have to fit them. We just know they're going to work, and then we can do some modifications of them afterwards. Another thing is dye sublimation. Dye sublimation is kind of cool. The eyes here are dye sublimated. You can see there's basically, it's taking ink in a printer, and I'm using a heat transfer to transfer it like impregnate it into the plastic in the eyes. So this is like computer fan mesh. It's pretty popular for dye sublimation. You'll see eyes down in the dealer's den that are made this way, but I can scratch it. It's not going to have any issue. Whereas I used to like airbrush my eyes, and you get somebody scratches it the wrong way. If it was plastic, or you get alcohol sprayed on it too much, it will drip a little bit. Dye sublimation is so cool because it is in there. It is in that material. And people make all sorts of cool crafts out of dye sublimation. And the really cool thing is you could use pretty inexpensive printers to do that nowadays. There's all these third-party ink companies that make them for like the Epson EcoFlow, EcoTank is what the one I have. You can just print your eyes, meld them into the surface, and it's just like perfect. And because I'm using my iPad to do the art, I have it. I know it's going to be looking really good, really cute. You can see there, I used to do a lot of plush fursuits. I would make plush tags out of that. So printing that on like a very silky material, you get this really cool shininess. So that was a tag that I drew up and dye subbed into that for that fursuit. So dye sublimation is super cool little tech that we use. Another fun piece of tech is vacuuforming. Vacuuforming is something I got into more recently too. It's really cool for eyes, teeth, anything you want plastic, but you want it to have a gentle curved shape. So cool for that. Basically all you're doing, the machine down, you can see on the bottom right, the machine at the top has a heating element, kind of like an oven, just the coils of wire that heat up the top. And then once it hits a certain degree temperature, you can see it like starting to sag. You turn on a vacuum, you pull the handle down, and it vacuums the soft plastic material around what's called a buck. A buck is the mold that you use, and it makes that shape. And once it cools down, you now have a piece of plastic that is that shape. It's still a little flexible, which is kind of great, but it also is like bent nicely curved. You can create some really cool curves and stuff to create those shapes. What's really neat about it to me is this works in conjunction with a 3D printer really well. I use my resin printers to create those bucks you see on the bottom right. And the resin printer does a really good job. I don't have to do any post-processing. I just like sand it lightly, put a little bit of like talcum powder or baby powder on it to keep it from sticking too hard, and let the machine go, and it just works. So yeah, it's a really cool piece of technology that we can use for fursuit making. And there's lots of blueprints to make this yourself. So it's not incredibly hard to make something like this yourself for $100. You can find use any vacuum cleaner with a pegboard, and you can use like a toaster oven to heat your material and some aluminum extrusion, and you could just make it yourself. I bought one because I saw it on sale, and I was like, I think it's cool. But you can just make this yourself. Adam Savage, I don't know if anybody's familiar with Tested. Adam Savage has one of these that is like handmade. Like it looks like he's got a really nice one, but he's also got one that he just made himself, and it's super easy to use. There's a place called Tap Plastics in most big cities. You can buy your plastic sheeting at that place, and they are very knowledgeable even about this process, and you can use that to help you figure out what you're doing. So that is a vacuuforming. Electronics. Oops, sorry, I keep doing that. I'm sorry. Electronics. Sorry. So we have a bunch of cool things with electronics. I've been slowly diving into this area myself. I'm not an expert, but I have friends who are way nerdier than I am, so they help me out a lot. But this little guy has these like readily available parts that you can just buy online. There's a company called the Tail Company you might be familiar with. They made the hardware for this and the tail for Vortex, so I could do things like have them move around just using an app. There's like controls based on my movement, based on, I can just have it do it randomly from time to time, or I can have it controlled from a controller remotely. But there's also just stuff that you can do, like Adafruit's website is an extensive repository for technology and knowledge of how to use it. There's so many people that are like, oh, I just wanted to make this cool sword from the video game and make it light up like it does. Here's exactly how I did it. Here's every part you need to do it. Here's the software that I wrote to make it work. And you can use that to like modify it to create your own versions of things. The mask I showed you earlier used that. I think I used it from one of the like Link's swords from Breath of the Wild. One of the ancient swords had these cool lighting effects. There was a plan for this whole lighting effect thing, and I just used exactly the stuff they used in that, but then reprogrammed it with the help of my friend TK, who he did all this programming of making it look very different from what it looked like originally. But the bones are there to learn from, and there's so many people on those sites that are willing to help you too. So Adafruit is a great software company if you're interested in learning a little bit more about how to do that kind of thing. Adafruit, Adafruit, and they sell like the controllers, Bluetooth controllers. They sell the lights. They sell screens. They sell like anything you could think of. That place is the coolest. I love it so much because it's just really cool. I love it. And so yeah, so that's technology, lighting, movement, servos. There's a lot of different things available to us nowadays that are just really approachable. These chips are not that expensive, and they're just super useful for stuff. Like I'm working on a cosplay. I don't want to talk about too much because I don't want to jinx it. But in about 2 months, I'll have a cosplay that my goal is to add not only lighting, but moving eyes and eyelids. And I want him to have a voice box so he can make a whistle. It's like, I have all this stuff I want to do, but you know, starting kind of small and adding more parts to it as you get more experience, super helpful for that kind of process. So, oh, look at it, moving the lights up, moves. There's that mask again. So yeah, that reaches the end of my normal presentation. Oh, sorry about that abrupt transition. We went into Q&A after this, and it was a little hard to hear anything after that point. I wanted to thank you for making it to the end of the video. If you have any more questions about things in specific, I often try to answer questions here in the comments below and take those and make future videos from those ideas. If you want to support me, I have a few ways. First, just liking and subscribing helps a bit. I also have a Patreon, and those members who support me there will be shown after the video, as well as a little web store, which I'll have a link with for below. If you're interested in buying something small that will help support my work, that'd be awesome. Thank you again so much for coming, and I'll see you next time here on the Fuzz Academy. Bye.